Hello everyone, my name is Dr. Mohammed Hamdan. Today I'm gonna show you how to use EES software to solve an ideal Rankine cycle. So firstly, you need to understand Ideal Rankine Cycle, which is a simple steam power plant that has 4 components: pump, boiler, turbine, and condenser. The problem that we would like to solve where we have a Rankine cycle that has a steam that enters at 15 megapascal and 600 degrees C. The steam exits the turbine at 10 kilopascal. You can plot the process on a TS diagram, which look like this. It's from 1 to 2 isentropic process, 2 to 3 is isobaric process with heat addition, 3 to 4 isentropic workout, and then 4 to 1 isobaric heat rejection. We would like to write an EES code that helps us to calculate the thermal efficiency and the quality at the steam outlet. So the way we do it, we go to EES here, type EES, open your software. Once you open it, you're going to get a white screen like this. You can copy your problem from here if you want to keep it in front of you on EES. I'm going to add these wiggly brackets just to make sure that it's a text. Also, I'm going to change the font size. I'm going to increase it. So I'm going to go Option, Preferences, and I will increase the font size to 24. Hit OK. So now this is the problem that we have. We would like to know the property enthalpy, especially at every point here. In thermodynamics, we usually tell you that if you have 2 independent properties, then you can find all other properties. So at point 1, let's start with point 1. What do we know at point 1? Well, we know that pressure 1 is equal 10 kilopascal, and we know quality of 1 is equal 0. So we know the pressure and quality at point 1. You need to make sure that you're following the right unit system. Since 10, what does it mean? P of 1 equal 10. It's 10 kilopascal, so we need to go to unit system here and make sure we're using pressure unit kilopascal, temperature in Celsius, and energy in kilojoule. Once we write these 2 variables, we can go to Option, Variable Information, Thermodynamic Property, can select the fluid from the first list here, water, and then I can find enthalpy. And they ask you for 2 independent property. We know pressure and we know quality. So now you can make sure that you paste this here. So this is enthalpy of 1, you can modify it when pressure equal P of 1 and X equal X of 1. And look, this is the fluid, water. Also, we can find entropy, same procedure, Option, Function Information, Thermodynamic Property, make sure this is water, and then you can go for entropy. Also, 2 independent property, we're going to start with pressure and quality. Just hit paste. You get it here. Just make sure this is S sub 1, so entropy at 1, P equal P at 1, and X equal X at 1. Now we know we have 4 variables and 4 equations. Now we need to write this for the second point and third point. So what do we know at point 2? I'm going to copy this, copy C. So what do we know at point 2? Well, at point 2, we know that pressure is P2 is 15. So P2 is 15 kilopascal, which is 15 megapascal. And we know X2 is equal X of 1. It's an isentropic process between 1 and 2. Now we can find all other property. So if somebody asks me to find enthalpy, I'm going to copy this time, Control C, Control V. Just make sure this is at 2, pressure at 2, and quality at 2. So now I can find the, oh yeah, actually this is entropy at 2, S2 and S1. Yeah, I wrote quality. Entropy has to be the same. And here, X is not X, entropy equal entropy at 2. So now we added 3 variables. So we have 7 equations with 7 variables. We can go and move to point 3. So Control C, I'm going to copy this line here and just write point 3. What do we know at point 3? We know that pressure, so I'm going to copy it here. We know pressure at 3 is actually equal pressure at 2. Also, we know temperature at 3, which was given to us in the problem, it's equal 600 degrees C, so 600 degrees C. Now, we can find other property like enthalpy and entropy. I'm going to copy this, Control C, Control V. However, I need to update it, this enthalpy at point 3, pressure at point 3, but here we don't know quality, we know temperature. So I'm going to say T equal T at point 3. Similar, I need to do for entropy, this entropy 3, when pressure equal P3, and here temperature equal the temperature at point 3. So now we added another 4 equation, make the total 11 equation with 11 variable. Now we need to solve last point, which is point 4. So what do we know at 4? We know the pressure and we know entropy is equal. So I'm going to copy the whole 4 line here and update it accordingly. So this point is pressure point 4. The pressure at 4 is equal actually P1. So this is, I'm going to write it as P1. Entropy at 4 equal entropy at 3. And enthalpy at 4 is, if we know the pressure, which is pressure at 4, and entropy at 4. Now we added another 3 equations, so we get 14 equation with 14 variables. Now we solve all the property, all enthalpy is known, I can find heat and then find efficiency. Also remember we need the quality at point 4, so I can go to option here, say function information. Again, remember this need to be water, and now here we need quality. So quality, you can find it here. You need 2 variables, so I'm gonna keep it as pressure and entropy, and just hit paste. So now you see X at 4 equal pressure at 4, and entropy is known. So we know entropy and pressure. Now I can solve. So you can see I solved, there is no any error except the unit, so we need to make sure there is potential problem with the unit. So we'll go option and variable information. Here you can update your unit used. So for example, for enthalpy it's kilojoule per kilogram. You can drag from here the first 4. Pressure you can write it as kilopascal. Also you can drag it for the first, another 4 variables, pressure. Entropy is kilojoule per kilogram degree C, and I can drag this here. Temperature is in degree C, and quality doesn't have units. I can hit OK and run. Voila, we have no unit problem. So far we found all the enthalpy. Our next objective is find the efficiency. To find efficiency, we need to find Qn, which happen between point 2 and 3. So I can write it as H3 minus H2, and I can find Q out equal, which is Q out what happened between 4 and 1, so I can write it as H4 minus H1. And eta, the efficiency, is just 1 minus Q out over Q in. And if I do the calculation, here I can find the efficiency is 43%. And Q in and out is here. The unit for it is kilojoule per kilogram. I can update the unit by going to variable information and just find the Q in here, and Q out, just type kilojoule per kilogram for the unit. So kilojoule per kilogram. And OK. And we can solve for these property. Now one thing we would like to see is plot the property plot. So I can plot the TS diagram for water. So here, this list here is for fluid. So I'm going to go to the end, select water. I'm going to plot the TS diagram. They ask you what pressure value you need. You can go with default, or you can write your own. So I'm going to go with the default. So this is the TS diagram. I can plot on this TS diagram each point so I can show the cycle. For example, I can add any plot. For example, here I can say this is point 1, for example. Right click or property, and you can change it. For example, fill it with color. So this is point 1, and then I'm using pump to go to pressure at point 2. So isentropic. Then I have go to superheated. Then I have going to the, oops, this is, I can delete it. So mixture, and I can extend line just to show you the process from 1 to 2, and again I can do line, change the quality, whatever so I can draw the process here. Also I can optimize the process. For example, if I want to see the effect of P, the 15 meg here, P2, I can comment this, and now I put the study the impact of P2 on the analysis. The way we can do it, we can go create table, new parametric table, and here let's say we want to see eta as function of P2, so I'm going to analyze these. Okay, I'm going to fill the value of pressure. You hit the top arrow here so you can fill the pressure, and let's say I'm going to fill the first value from 10,000 or let's say from 5,000 kilopascal to 15,000 kilopascal. If I want to see how the efficiency change, I can hit run here, and I can see how efficiency change. And you can see that efficiency increase with the pressure of the inlet and the turbine. And I can plot this by going to plot, new plot, XY plot, and I can plot on the X direction the pressure, on Y axis eta, and you will see how pressure or efficiency change with pressure. So this is just a simple introduction to Rankine cycle, how to solve it using EES. I hope this was useful for you. If you have any question, please write it in the comment. I'll be glad to answer your question. Thank you for your listening, and you can see other videos on EES for auto cycle and other thermodynamic cycle. Thank you very much.